Alright guys, today we are going to learn about the disk method and how to use integration to find the volume of solids using the disk method. First of all, when do you use the disk method? You use it when, first and foremost, the rectangular strip that you are rotating around an x-axis or y-axis, it must be connected to the axis that you are rotating it around. That's the first thing that has to be true. Second of all, the rectangular strip must be perpendicular to the axis of revolution. Alright, so if you are rotating this around the x-axis, it needs to be a vertical strip, which means it's going to be a width of dx. Or if you're rotating it around the y-axis, it's going to be a horizontal strip with a width of dy. So let's just kind of see how this works out here, and these things are things that you really have to visualize as much as possible. So let's say we have the x-axis here, and let's say the curve that we're given is just something simple like y equals x squared. Alright, and we want to take, let's just say, a strip, and we want to rotate that around the x-axis. Alright, so if you can kind of visualize, I'm going to draw another strip over here, and you can kind of see that I'm not the best artist here, but if you rotate this around, alright, it's going to form the shape of a cylinder, and it's going to have some sort of thickness associated with it right there. And so you can see here that, actually, you know what, that's not a good representation. Let me go back and do that again. So there we go. And so you can see that this guy is going to end up you're going to rotate around the x-axis, and it's going to create some sort of cylinder. Alright, and so that's the shape that you're going to have. So if we were to lay this shape out flat, it would look something like this. Alright, so that's my best attempt at a cylinder. Alright, and it's going to have some sort of thickness to it. And our goal is to find the volume of one of these discs, or one of these cylinders, if you will. Well, we know from geometry that the volume is going to be the area of the base, and the base is a circle for all of these. So the area of a circle is pi r squared times the height, and the height is going to be, will just be pi r squared h. In our case, the height is going to be the dx, alright, dx. Now, the radius is going to be, so let's just go back here and look at our problem here. So if I call that point right there x, y, well, y is the distance from the x-axis. So therefore, y is going to be your radius. So in our equation, we have y equals x squared, just a simple parabola. So our radius is going to be x squared. So we're going to take that, we're going to plug it into our volume equation. And so what we have here would be the volume of just one of these discs is going to be pi. R is x squared, because you have to square the radius, and the height, once again, you have to imagine this thing laying up and down as opposed to flat. So the height is just going to be dx, as we've seen in the other problems. And so that's going to give us the volume of just one disk, and let's say we want to find the volume of this entire region with everything just kind of making a big solid. Alright, then let's say we're integrating from 0 to 1, so we would integrate this from 0 to 1 bring the pi out, and it would be x to the fourth dx. So it would be x to the 5th over 5, and then you'd plug in your upper limit and your lower limit, and you would end up getting pi over 5, which would be the volume of that entire region. So that is the idea, and that's what we're going to work on in the next few slides. All right, in example 2, we are given the parabola. So let's just write this out here. We are given the formula y equals 4 minus x squared, and so that's going to be a parabola shifted up 4 and upside down, so it's going to look kind of like that right there. And so what we want to do is we want to take this region that is in the first quadrant, as you can see on your graph. So it's going to be this region right here. And we want to take that and we want to revolve it around the x-axis. So this, in our green, represents our representative rectangle, and we want to rotate that guy around the x-axis. And so if we call this point here x, y, we can see that y, once again, is our radius. All right? And so we are going to integrate this from 0 to 2. So 0 to 2. And once again, if you look at your formula, the volume of a cylinder is pi r squared h. So pi comes out there. Our radius is the y coordinate, so that's going to be 4 minus x squared. And you have to square that. And then dx is making it volume. All right. And so this first one we will do by hand. And so when we square this, it's going to be 16 minus 8x squared plus x to the 4th. And integrating from 0 to 2 and pi. And then we end up getting 16x minus 8x cubed over 3 plus x to the 5th over 5. And we're going to plug in our upper and our lower limit now. You go through the process and you will end up getting 256 pi over 15. And that is the answer to this problem. All right, example 3 looks like we've got a part of a circle. And so I'm going to draw that in here. Looks like the radius is 4. So we have that. And I'm going to shade in the region. So this is the region that we would like to rotate. And in this particular problem, it says that we should revolve it around the y-axis. So we are going to draw a rectangular strip. All right, and we're going to rotate that around the y-axis. So we'll call this point x, y. And so in this example, what is the radius? So maybe we'll do that, call that r. The radius of our cylinder, because don't forget, when you're wrapping this around the x-axis or any axis, remember it's going to create a cylinder, and so the radius here is simply x. So let's write that down. Radius equals x. All right? So this is going to be a strip that has a thickness of dy. So this is a dy strip. So that means everything in this problem needs to be in terms of y. The lower and upper limit of integration needs to be in terms of y, and also the formula that you integrate needs to be in terms of y. All right, so we're going to take our formula, which is y equals the square root of 16 minus x squared, and we're going to solve it for x. So we're going to square both sides, and we get y squared equals 16 minus x squared. Move some things around, and we get x squared equals 16 minus y squared. All right? So if we want to solve it for x, we can, but you're going to see later we don't really need to. So x will be equal to the square root of 16 minus y squared. So that is our radius. All right, that is our radius. So we need to integrate this, and we use our formula. So we're going to integrate from 0 to 4, and pay attention, that is along the y-axis, happens to be the same number as the x-axis. So we're going to integrate from 0 to 4, pi, don't forget the pi, radius squared. So when you square x or square the square root, it's just going to go away. So you're going to get 16 minus y squared, and then dy. Okay, so just so you don't forget, we're squaring that, and the square root goes away. All right, so once again, from here, what you want to do is you want to integrate this one by hand. So that's going to give you 16y minus y cubed over 3. Plug in your upper limit and your lower limit of integration, and you get 128 pi divided by 3. And that is the volume of this particular shape. All right, this last example is actually a great example on the use of the disk method. And so it says find the volume of the solid generated by revolving the region bounded by the graphs of the equations xy equals 6. So let's write that out. Xy equals 6, y equals 2, y equals 6, and x equals 6 about the indicated lines. Well, part A says we need to wrap this region around the vertical line x equals 6. We'll get to that in just a second. So notice we don't have a picture or anything given to us, so we're basically out on our own. We've got to figure out what this picture looks like. All right. So if we solve this equation for y, we end up getting 6 over x. And you may not be familiar with what that looks like, so maybe we make a table and we'll say x, y. All right, so when x is 0, can't plug in 0 because can't divide 6 by 0, it's undefined. So we'll plug in 1. When we plug in 1 for x, we get 6 for y. Plug in 2 for x, we get 3 for y. Plug in 3 for x, we get 2. So at least we can plot points. Don't forget, if you don't remember the shape of something, you can always plot points. So we're going to come back to that in just a second. And first, let's put the lines that we do know. Y equals 2, so that's going to be there. And y equals 6, that's going to be there. And x equals 6, that's going to be there. And once again, maybe we'll put 1, 2, 3, 4, 5. So 1, 2, 3. And we've already figured out that for the xy equals 6 graph, when x is 1, y is 6. So we'll put that point there, because don't forget, this is the line y equals 6. Oops. This is the line y equals 6, and this is the line y equals 2. So x is 1, y is 6, x is 2, y is 3. All right, so that's going to be maybe right there. And when x is 3, y is 2. So looks like some sort of reciprocal function. We should have known that already anyway. And we want to take this region, all right, so it is this region right here. And we want to take that region and we want to rotate it around the line x equals 6. All right, so why don't we call this point right here, we'll call that some point x, y. All right, so if we draw our rectangular strip, draw our strip, and in green here, That is our rectangle that we want to rotate around the line x equals 6. Now, the tricky part with this is you got to figure out what the radius is. All right, if this is the line x equals 6, and this distance right here is x that I'm outlining right here. Well, then our radius is going to be 6 minus x. All right, the entire distance, 6, minus the x distance, gives us the green distance. All right, so our radius is going to be 6 minus x. All right, so that lets us know that we need to solve this equation right here for x. So that's just going to be x equals 6 over y. Okay, so our radius in terms of y we can say is 6 minus 6 over y. And at this point we just basically plug this into our formula. All right, and we are going to say our integral is going to be pi times the radius squared. The radius is 6 minus 6 over y squared. dy is the thickness, so I'm outlining that right there. That's your thickness of this cylinder. And so we are integrating, everything is in terms of y, so we are integrating from y equals 2 to y equals 6. So those are our lower and upper limits. And if you plug that into your calculator, you will get 241.58. And that is the volume of this particular shape wrapped around the line x equals 6. All right, in this last example, part B to example 4, we want to take the same region and we now want to rotate it around the line y equals 6. Now, notice here there's a problem right from the beginning. We need to break this up into two regions. Because if you notice here, if you draw a rectangle here, that is not going to be the same rectangle in this region right here. The red rectangle has a radius. Well, let's just see what the radius is. If you make this point, once again, x comma y, well, the radius is going to be the entire distance 6 minus that y value. So 6 minus y is going to be the radius. Once again, I am calling this distance r, the radius. Okay, so you've got to do 6 minus y. All right, and this is a dx strip. So that means everything needs to be in terms of x. So y, don't forget, was defined as 6 over x. So the radius, and tell you what, why don't we just do this? We'll call this region 1. Region 1. Okay? And we will call this over here, call that region 2. Okay, so in region 1 we are going to find the volume using the disk method. So it's going to be the integral from 1 to 3. You say, well, where'd you get 3? Well, don't forget, in the first example, remember that point was 3, 2. So we're going to integrate from 1 to 3 of pi times the radius squared, and the radius was 6 minus 6 over x. So 6 minus 6 over x, the radius squared dx. Okay, and if we use our calculator, we're going to approximately get 53.09 for that integral. It's going to give us the volume. Now, region 2, there's a couple ways of doing this. You could do region 2 and you could use calculus. Okay, you could integrate the radius. So the radius, okay, the radius here would simply be 4, right? 6 minus 2. And you could integrate that from 3 to 6. Or you could use geometry. You could just imagine this rectangle being rotated around this line. So it's going to form a big cylinder. All right. So the formula for a cylinder, once again, is pi r squared h. All right. So if we just wanted to basically just find the volume of the cylinder, so we'll just say volume of the cylinder, all right, is going to be pi, and the radius is 4, and the height is going to be 3, because 3 is the distance from 3 to 6. All right, so you need to kind of imagine that, make sure that makes sense to you. All right, and so you're going to end up getting 48 pi as the volume of that second region. So when you add 53.09 to 48 pi, you end up getting 203.88. So to be technically correct, we need to use approximately. So approximately 203.88. And that is the volume rotated around the line, the horizontal line, y equals 6.